Alright, so now we're going to start Unit 7, which is atmospheric air pollution. And our first topic is topic 7.1, Introduction to Air Pollution. Our objective today is to identify the sources and effects of air pollutants. And we're going to be looking at air pollutants in general, and then each of the topics after this is going to kind of go a little more in depth for different things that cause air pollution and ways that we can clean them up. We have, actually let me go back real quick, we have a bunch of vocabulary today because we're looking at these major air pollutants, again because it's an introduction, and so you're going to have an activity that you're going to do periodically throughout this unit to help you become very, very familiar with these words, because you need to know not only where each of these chemical pollutants come from, but how we can clean them up and whether they're primary or secondary pollutants. Okay, so the first thing that we're going to look at is air pollution released by coal combustion. And anytime you hear the word coal, there are a handful of things I need you to think of. The very first thing is sulfur dioxide, or SO2. Sulfur dioxide is released by burning coal. If you remember when we talked about anthracite versus bituminous coal, A coal and B coal, A coal was the best of the coals because it had the least amount of sulfur in it, but it was also the least plentiful. Bituminous coal we have more of, but it has a high sulfur content. Whenever we burn that, in the presence of oxygen, we get sulfur dioxide, and if that reacts with rainwater in the atmosphere, it becomes sulfuric rain. So coal combustion, automatically you need to think sulfur dioxide. The other thing you need to think about in coal combustion is mercury. There are trace amounts of mercury, which is a naturally occurring metal, in coal, and when that is burned, it is released into the air. It can fall into aquatic ecosystems, and that's when it becomes the real problem, is in aquatic ecosystems. Bacteria convert it to something called methylmercury. That should just say mercury, not whatever it says right now. And we need to know that that type of mercury, that methylmercury, can become a neurotoxin, and we'll see some more about that. Anytime you're burning or combusting a carbon-based compound, you're going to get carbon dioxide, which we know is a greenhouse gas. Coal combustion also produces a lot of soot or particulate matter. It's the black smoke particles that are created, and that blocks sunlight and also acts as a respiratory irritant, so it can cause lung disease or exacerbate pre-existing conditions like asthma or COPD. Carbon monoxide is another thing. If carbon dioxide is produced, almost always carbon monoxide is also produced. Carbon monoxide is the thing that people get, like if they run generators in their garage and it's closed, they get carbon monoxide poisoning, and you can die from that. It interferes with the hemoglobin transport of oxygen in your blood, and it always comes from the incomplete combustion of carbon. And then lastly, nitrogen oxides, which we just make NOx, and that might be NO, NO2, or NO3. And all of those are part of something called industrial smog, which we'll learn about in later units. So these are our coal combustion air pollutants. And so you can see here, this is just a little visual, and it talks to you about black carbon. Is kind of part of that particulate matter, the soot. Also sometimes called fly ash. It's what's left over after carbon is burned. Think about like what's in, if you have a charcoal grill, after the charcoals are burned down, what's left over, that's fly ash. The sulfur dioxide can become acid rain. We talked about the mercury can become a neurotoxin impacting your nervous system. And then those NOx's are a part of industrial smog or ground level smog. Okay, so let's take a couple of them and talk a couple of those pollutants to talk through. The first we're going to talk about is mercury becoming methylmercury. Mercury in its own is actually not as hazardous as you think it would be, because it does not accumulate in the fats of animals. Methylmercury, on the other hand, can accumulate in the fats of animals and therefore moves up the food chain, that bioaccumulation or biomagnification process. And so basically what happens is mercury, released from, like, say, a coal burning power plant, reacts with aquatic bacteria. And in that transformation, we get methylmercury. Methylmercury then can be accumulated in the fats, and so small amounts end up in something like, say, krill, and then those amounts accumulate as you move up the food chain, and that's why there are certain fish that you should or should not eat, particularly for women, as that mercury is stored in your body and would be exposed to a developing fetus. Okay, one example of what happens when you're exposed to methylmercury has to do with something that happened in Minamata Bay, which is a fishing village in Japan. When you open up this PowerPoint presentation, you will see that there's a link up here for a very short video about Minamata Bay disease. I really want to encourage you to watch this so you can understand what I am talking about when I talk about it being a neurotoxin. Basically, a chemical company was releasing mercury out into the ocean. It was just dumped into the ocean in a fishing village in Japan. And so that mercury was converted to methylmercury by those aquatic bacteria. It is important to know that they are anaerobic, so they do not require oxygen in this process. I spelled mercury wrong again. But so it's converted to methylmercury, and then bioaccumulated up the food chain. Well, in this Japanese fishing village, it was accumulated into their food, and there is a generation of children who were born with extreme neurological birth defects. But it's also something called the dancing cat disease. And so I want you to watch the video on Minamata Bay so you can understand what we're talking about. We're talking about the dancing cat disease. And so I think just recently they considered the bay cleaned up, but it had been over 30 years of cleanup in order to get the methylmercury to levels that were not as toxic as they once had been. Okay, the next thing we're going to look at is we're going to look at air pollutants released by fossil fuels in general. And so remember, when we're talking about fossil fuels, we're talking about coal, oil, and natural gas. We've already covered coal, so we're going to be looking particularly at oil and natural gas. Since we're talking about the combustion of a carbon-based compound, we're talking about CO2 and greenhouse gases. Anytime we're talking about CO2, we're also talking about carbon monoxide, because that's the incomplete combustion. And we know that it reduces the oxygen carrying capacity of our blood. Those nitrogen oxides, again, they're part of the precursor to ozone, or what we call smog in cities, are these NOx's. And also it can become nitric acid in the atmosphere, which becomes another type of acid rain. There are traces of sulfur compounds, so they could generate some pieces of sulfuric acid, but again, anytime you think of sulfur, sulfuric acid, sulfur dioxide, any of that, your mind needs to go straight to coal. We release things called VOCs. VOCs are just volatile organic compounds. All that means is it's a compound that's carbon-based, that it could be a liquid or a gas that very quickly evaporates into the atmosphere and becomes part of the atmospheric air. Oftentimes these cause respiratory illness. They can increase your cancer risk, and they're a part of the formation of smog, and then also, again, particulate matter, because anytime you burn things, you're going to have small amounts of soot. Okay, so here's an image of our fossil fuel combustion. Fossil fuels are made up of carbon and hydrogen with trace amounts of nitrogen, sulfur, and oxygen. It's important that we know that. Sometimes we call it CHONS, C-H-O-N-S. Just remember that the O is actually the last, because these are in order of percent composition. So it's mainly carbon and hydrogen with smaller amounts of nitrogen, sulfur, and oxygen. Okay, and so we talked about here the pollutants, and we've talked about carbon monoxide, carbon dioxide, and the VOCs, etc. Okay, sulfur dioxide. Again, sulfur dioxide, our main source is always going to be coal combustion, particularly that bituminous coal, or the softer coal, which has greater sulfur amounts. When we look at sulfur dioxide in a map of the United States, we can see that we're going to have a lot of sulfur dioxide in areas that are well populated. You don't see a bunch out here in the Midwest, because power generation in these areas through coal burning power plants. You see much of it is on the East Coast, but that's because most of our coal is right here in the Appalachian Mountain chain. And so transport means, that coal is going to be burned on the East Coast. But it does also come from combustion of oil and natural gas, which is why you see hot spots of it in the metropolitan areas of the western side of the United States. There are some natural sources of sulfur dioxide. Volcanoes and geothermal vents also both release sulfur dioxide, but that's part of the normal atmospheric composition. We're worried about coal and combustion of oil and natural gas because they're adding to it. Okay, let's talk about fuel. Particularly this idea of unleaded fuel. If you've ever gotten gas, you've probably seen that it reads unleaded. There's different varieties or grades of fuel, but they all say unleaded. All fuel in the United States must be unleaded. That's been something that's been the case since at least the 70s. But it used to not be the case. We used to actually add lead, or PB, on the periodic table to fuel because it was improving engine performance. And so that was a great thing. There's even some statements we say, like taking the lead out, meaning slowing something down, because it can improve engine performance. But it was released in that combustion and it entered ecosystems. Lead is a neurotoxin, and so it was impacting the neurological development of animals and people, and so now we have unleaded fuel. It's not the case globally. There is still leaded fuel, but here in the United States it must be sold as unleaded. Okay, so what happens if you're exposed to lead? Particularly we worry about children because their neurological systems are still developing. And so they can be exposed to lead through leaded gasoline, through paint. In the United States, paint cannot have lead in it. It's only if you have old paint that it may have lead. So like when we bought our house was built before the 70s, and so we had to sign a lead waiver, meaning that, if we were chipping away or changing drywall or something, that we needed to wear masks because there's the possibility that there's lead in the paint that was used. Sometimes you'll hear this come back up in the news when we buy things from other countries, like when we import goods from other countries, particularly with children's toys. They were being painted in other countries. Usually China gets the rap for it. Painted with paints that were lead-based paints, and kids put those toys in their mouth and they chip off pieces of that paint, and then they get lead. You also hear about lead in the Flint, Michigan water crisis. There was lead in the pipes, and through a series of really terrible mismanagements in the water system process, the lead was being released from those pipes when it shouldn't have been. Many types of makeup, particularly red lipstick, contains lead, and you can actually test this by putting, if you have red lipstick, swiping it on your hand and making sure you have a gold piece of jewelry, it has to be true gold, and rubbing it over that, and if it turns black, it has lead in it. So many makeups have lead, and then jewelry also can have lead in it. And even I read recently that glossy flyers that you get in the mail, the paint or ink that they use to produce those may have lead in it. So you should just be cautious about any types of paint. So why do children typically get exposed to lead? Well, in many of these things, like old paint chips, kids would be, low to the ground, and so if paint was chipping off, they may be exposed to it as they're crawling around and kind of, shuffling dust around. Also, babies and small children like to chew on things. So an old crib or old toys, if they were to chew on them and those bits of paint would flake off, it would get into their body. So it causes damage to the brain and nervous system. It slows their growth and development. It can cause learning and behavior problems, speech and hearing problems. Together, those lower the IQ, decrease the ability to pay attention, and lead to an underperformance in school. And that's just being exposed to lead. Okay, so talking about the environmental portion of this, there are these giant birds in the western side of the United States called California condors. They're basically like a cross between an eagle and a vulture. They are not the prettiest of animals, but as you can see here, they are very, very large. And basically what their method of eating is they are a detrivore, so they eat dead things. And so they use this huge wingspan and they just glide up in the air and they look for something dead, and once they see it, they go down and they eat it. Well, they consumed high amounts of lead in the process from both gasoline emissions on the West Coast and from lead shot in animal carcasses. So like hunters would shoot a carcass and there would be lead shot. The bullets would have lead in them. As they were eating the meat, they were consuming it, and then it was acting as a neurotoxin. The population was decimated, and so we did something called a captive breeding program. We took in the remaining individuals that we could find, we bred them in captivity, and then we trained the babies up and then released them back in the wild. And it's been a relatively successful program, but it's one of the first to use that captive breeding. So anytime you think of lead, I want you to think of the California condor and the captive breeding program. Okay, almost done. Let's talk about the difference between primary and secondary air pollutants. So remember, primary means first, secondary means second. So a primary air pollutant is something that is directly from the source, coming right out of the tailpipe or the emissions pipe. So NOx's and VOCs, volatile organic compounds, and nitrogen oxides. Both of those were primary air pollutants. They were created from the combustion of coal, oil, natural gas. Once those compounds get into the air, they can undergo other chemical reactions, and they can become something else. If that happens, it's called a secondary air pollutant. Most of those reactions are involving oxygen, water, and or usually sunlight. Those are called photochemical reactions, meaning they occur in the presence of sunlight and they're not happening at night. So for example, when you take NOx's and volatile organic compounds and sunlight, you get photochemical smog. Photochemical smog is always a secondary air pollutant. Well, NOx's and VOCs are harmful, but they're not as harmful as photochemical smog. So the next question is, well, if we need to deal with photochemical smog, how do we get rid of it? And so, or if we're talking about sulfuric acid making acid rain, nitric acid, ozone, which is photochemical smog. These are all things that we really, really are concerned about because they harm not only the ecosystem, they also harm humans. The only way to deal with these is to first deal with these primary air pollutants. And so, should we regulate primary or secondary air pollutants? Although the secondary air pollutants are often more harmful, they can only be prevented if we deal with those primary pollutants. So we have to start controlling the burning of coal, oil, and natural gas, and the emissions that come from that if we're going to deal with these more harmful secondary air pollutants. Okay, before we go to your next section, I want to just take a second and make sure that we have covered all of our vocabulary words. So flip back with me. Let's look at your vocabulary words. We've talked about carbon dioxide, sulfur dioxide, and sulfuric acid. The toxic metals that we're talking about, we didn't really define those, are mercury and lead. Those are the two that we are looking at. So if you want to jot those down, since I didn't cover them in the presentation, mercury and lead. And so then we talk about mercury and the harmful form of it, methylmercury. We know about bioaccumulation, or the building up. We've got particulate matter and nitrogen oxides. You're going to start hearing the baby in a second because she's starting to grunt and move. Nitrogen oxides, we talked about those NOx's. Tropospheric ozone, I didn't go into that a lot yet. Tropospheric ozone we will cover in other units as well. But tropospheric ozone is ground level ozone, or also known as photochemical smog. And so we did talk about photochemical smog. Those are all possible names or synonymous. Tropospheric ozone, ground level ozone, or photochemical smog. Anytime you hear any of those terms, they are all related. Nitric acid, we talked about that HNO3. Acid rain, which is composed of HNO3 and H2SO4, or sulfuric acid. Carbon monoxide, we talked about from the incomplete combustion. The Clean Air Act, we did not cover that yet. The Clean Air Act is part of what regulates our primary and secondary air pollutants. And so we will spend some more time in that when we talk about law, but just for right now, we need to know that it's the piece of U.S. legislation that regulates air pollutants. Unleaded fuels, we've talked about. Lead, we've talked about, and we discussed the difference between primary and secondary air pollutants. Okay, so we've covered those. We know that our objective is to be able to identify the sources and effects of air pollution. and I think that we have done that. So let's talk about your textbook connection. So you're going to be in chapter 19 in the textbook, and you're going to look at sections 1 and 2. For the next couple of topics, you're going to kind of be in 1 and 2 several times. So, you don't have to stress out about being able to answer all of those checkpoint for understanding questions yet, because we're going to hit them in other topics. Just make sure by the time we finish this unit that you are that you're done with all of them. Okay, so you're going to put that on one sheet of paper called Chapter 19 Checkpoints, and you're going to start working on Sections 1 and Sections 2. Okay, so for your activity page for this topic, what I want you to do is you're going to divide the page into 4 boxes, and then you're going to go back to that vocabulary list, and you're going to pick 4 of the air pollutants that are listed in the vocabulary list that you found to be the most interesting. And then I want you to, in each of those boxes, tell me the source, the chemical reaction involved. If you look at in your textbook table 19.1, might be able to help you there. Or you can just look it up online. Tell me one way to reduce, clean up, or control, deal with the pollutant. You probably will have to research that, so make sure you look up one way to deal with it. And then a picture to demonstrate either the effect of that air pollution or the source of that air pollution. You need to use 4 or more colors, and that will cover your activity for 7.1. Okay, so that covers atmospheric air pollution, and go ahead and get started on your next piece.